In this home experiment, you'll be preparing a number of different solutions of salt and sugar and determining their molality, at which point all of the solutions will be placed in a freezer and you can record your observations as each solution freezes. The different molality of the solutions will impact the temperature and therefore the time it takes for the solution to freeze. The water used to prepare your solutions should be left out ahead of time, either for a few hours or overnight. This is to ensure that the temperature of the water is uniform and can be known. That way you can determine from the density the mass of water used in your solutions. Temperature plays a key role in a number of different chemical reactions and processes, from the kinetics or speed of the reaction to the thermodynamics and equilibrium. Temperature also plays a role in affecting the density of a given material. In your home experiment, you can use your thermostat to determine what is the temperature of your liquid samples and determine the density of the water and alcohol samples. At this setting at the moment, the temperature is reading 73 degrees Fahrenheit, which should be converted to Celsius in order to determine the density from varying tables online. In preparing your salt solutions, you will take exactly 1 teaspoon of salt and add it to a container. The salt solution should be leveled off in the teaspoon so that way you have exactly 1 teaspoon of salt. This way you can accurately determine how many moles of sodium chloride are being used to prepare the solution. The nutrition information on the salt packaging lists the mass of 1/4 teaspoon as 1.5 grams. Therefore, 1 full teaspoon of salt should weigh 6 grams. Likewise, the nutritional information for sugar lists the mass of 1 teaspoon of sugar as 4 grams. From these masses of sugar and salt, you should be able to calculate how many moles of compound are added to your solutions. Next, you will take the indicated number of tablespoons of room temperature water and dissolve the salt. Please note, for the highest concentrations of salt, this will take a few minutes so the salt can completely dissolve. You only need 1 tablespoon of each solution in the end. You can prepare these different solutions either in a number of small containers or in one continuously used container. It is easier if using a single container for the mixing to prepare the lowest concentration first and then remove the 1 tablespoon of solution needed, rinse out the glass, and then continue on to the next solution. When your salt solution is dissolved, you can take 1 tablespoon of solution and add it to either a small container or 1 well of an ice cube tray. You will do this for each of the 5 salt solutions, as well as a prepared solution of sugar and of rubbing alcohol or isopropyl alcohol. All solutions in the different containers should be placed in the freezer at exactly the same time. This is easiest with an ice cube tray. Over the next hour, you will then take observation readings of the different stages of freezing of the different solutions. You will record your observations at 10-minute intervals over the first hour, and then at a total time of 90 minutes and 120 minutes. Last, you will leave the solutions in the freezer overnight, and the following day, check to see if there is any change. As with the salt solution, the sugar solution and the isopropyl alcohol solution will be prepared in the same way. However, it will require you to perform small calculations ahead of time. The experiment asks for you to prepare a sugar solution and a rubbing alcohol solution that will freeze, at least to some extent. You'll record exactly how many teaspoons of sugar you use in your solution, as well as how many tablespoons of water. Likewise, you can record how many teaspoons or tablespoons it could take when you prepare an alcohol solution, as well as how many tablespoons of water. Keep in mind, the water should still be at room temperature. Overall, you should be able to see a relative trend that relates to freezing point depression and molality, as well as the different observations upon the level of freezing of the water.